So let's learn the concept of upwelling and downwelling. I already used this term a couple of times. Turns out to be another very important concept because this is a way that the ocean circulation affects the chemistry and biology. For example, the uptake of carbon and heat by the ocean very critically depends on upwelling in some places. Okay, there are other processes, but upwelling is very important. Production of fish. Okay, fisheries grounds tend to be very critically dependent on upwelling because, as I briefly mentioned, upwelling brings cold waters but also nutrients, leads to photosynthesis, phytoplankton, and hence ultimately fisheries, right? So what is upwelling? It's basically a vertical movement of cold, nutrient-rich waters. Remember that the ocean currents only move at order centimeters per second, very slow, which means the water moving up will be even slower because it has to replace the water that's moving away horizontally or converging horizontally. So water upwelling tends to be only a few millimeters per second, a few meters per day. Okay, that's something you have to remember. So high biological productivity or abundance of photosynthetic algae, which serve as the base of the food web, tend to be in upwelling regions. Downwelling is where convergence happens and surface water sinks or goes down. Okay, how does upwelling happen? Again, you have to apply your Coriolis here. We had the southeasterly trade winds blowing across the equator into the ITCZ, which was mostly to the north of the equator in the Pacific and Atlantic Oceans, right? So what happens when the wind is blowing across the equator? Remember that equator is like a dynamic boundary where the Coriolis goes to zero, and the currents to the south of the equator are pushed to the left, to the north of the equator they are pushed to the right. So even though winds are blowing across the equator, they are approximately carrying wind westward, the currents, ocean water westward on both sides. So ocean water on both sides is moving away from the equator, so there is a vacuum being created on the equator which is going to be filled by water that's being pulled up. Okay, that's what upwelling is. Obviously, we'll see that this can also happen at the coast. Anytime you create a divergence or a convergence, you create upwelling or downwelling. So this trade wind driven upwelling on the equator is obviously called equatorial upwelling. When convergence happens on the other hand, as we saw in the subtropical gyre, we had water coming south from the westerly wind forced eastward flow and northward from the westward pushed water by the trade winds, and you had a convergence in the middle. You had sinking of the water and high sea level, right? That's what happens here. So it's like sweeping in the warmer surface waters and pushing them down so that the thermocline has to go down, more volume of warm water, so sea level goes up, as opposed to upwelling where cold water comes up, it's denser and sea level is lower. Okay, so something we didn't mention before about this impact, we said the sea level changes by increases by almost 2 meters when we go from the equator to the middle of the gyre. On the Pacific, if you go from Galapagos to New Guinea, the sea level rises by almost 50 centimeters because waters are cold in the East Pacific, so the sea level is lower, pressure is higher. In the west, warm waters are piling up, forming this West Pacific warm pool. So thermocline is deeper, sea level is higher, so the ship is going uphill by half a meter as you go from east to west.